So proving inequation by using the concept of monotonicity of a function. For a monotonic increasing function, the graph of the function will be like this. Gradually it increases. This is a monotonic increasing function, mi function. It is not true that it has to go this way only. The graph of function may be like this also. Okay, this is also monotonic increasing function. Okay. Now, if a function monotonically increasing at any point, if you plot the tangent to the graph, then the slope of tangent will be a positive quantity. You draw it here. Am equal to tan theta, that is greater than 0. Here also at any point you plot, you draw the tangent. Just a minute. At this arbitrary point you have joined, the slope of tangent theta is acute, theta less than 90 degree, tan theta will be greater than 0 for a monotonic increasing function. Now, if fx is a increasing function in a closed interval a to b. Fx is an increasing function in a closed interval ab. Somebody asked you what is the maximum value of fx and what is the minimum value. If it is a monotonically increasing function, then in an interval a to b, what is the maximum value and what is the minimum value? It's like this. This point is a, comma 0. This one b, comma 0. Okay. In this interval, it is monotonic. You can see the graph. It is monotonically increasing over there. It is quite obvious that if fx is monotonically increasing, this is a statement. If fx is mi in AB, then f mean equal to A and f max equal to B. You must agree with this. It's quite obvious. Gradually it is increasing, no? So at this point it will have the maximum value, at this point it will have the minimum value. What about monotonically decreasing function? For a MD function, monotonically decreasing function, this one, see, this one is a monotonically decreasing function. You can take it a curve also. Now, for this monotonically decreasing function, if we consider this interval from A to B, we are considering monotonically decreasing function in the interval A to B. Then maximum value occurs at A, minimum value occurs at B. So the statement will be like this: for a MD function, I mean monotonically decreasing function, fx in AB, the maximum value is at A, f maximum occurs at, here remember f minimum occurs at A, f maximum occurs at B. So here f minimum at B and F maximum at A. F minimum value is what then? This is FB. F maximum is what then? That is FA. Okay. So in the previous case, F minimum is not A. F minimum occurs at A. F minimum, this should be equal to FA. F maximum should be equal to FB. For a decreasing function, just opposite case. Here for x equal to A, it will have maximum value, and for x equal to B, it will have minimum most value. Clear? Now, one more observation we can do. For a monotonically increasing function, in the interval A to B, this interval only. This point is A0, B0. For a amine function, if Fa greater than 0, then Fx is positive greater than equal to 0 also. You can say Fx greater than equal to 0, Fx is positive all along this interval A to B. You agree or not? The lowest point, the minimum most point is 0. Other points has to be greater than that. Or greater than 0, other point must be positive quantity. So if Fa greater than 0, Fx is positive in A. This is a very important concept. Keep this concept in your mind. And then another case I am drawing here. This is also a monotonically increasing function. You must agree. This point is B and this one is A. This is a monotonically increasing function. Okay. In this case, what will be your observation? Also, if FB less than equal to 0, then Fx is negative all along this interval A to B. Agree? So this is the case of monotonically increasing function. If Fa greater than equal to 0, it will be positive in A. Similarly, Fb less than equal to 0, it will be negative. This case we have discussed for amine function, isn't it? For amine function, it happens. Clear? These two cases you need to remember. Now, we are doing it for MD function, monotonically decreasing function. A function is MD in a given interval. Okay, let's do it here. For MD function, x, y, this is MD function. The interval is from y equal to fx. The interval being taken from a comma 0 to b comma 0. So if fx is MD in AB and FB greater than or equal to 0, then fx is positive in AB. isn't it? Fx will be positive in the interval a to b. And let us consider another situation for MD function only. All along the interval it can be negative also. MD function can take this form also, gradually decreasing. So this interval is again a to b, a0 to b0. So if fx is md and fa less than equal to 0, then fx is negative all along the interval ab. Am I clear? Whenever you are going to solve inequality problem, these four should be in your mind always. Okay? Now, let me explain how to compare two functions by using this concept of monotonicity. This kind of question is very common in JEE main and advanced examination, WBJEE also. Okay? Any problem on it you can tackle easily if you remember these four statements about MI or MD function. So you always imagine graphically what's going to occur. From there, if you find so in an interval to compare two functions, let me tell you. Suppose you want to compare two functions fx and gx. I mean, which one larger, which one smaller, all these we want to compare. To compare two functions fx and gx, we use step 1. What is that? Write fx equal to fx minus gx. Either fx equal to gx or greater or smaller. No other option is there. They have a common interval where you are going to decide in ABC. Take in the interval, just symbolic. Okay? Step 1, you write this. Step 2, show that fx is mi or md in interval. Which fx? That fx which is difference between these two. Okay? Step 3. For mi, consider two cases discussed above. For a monotonically increasing function, we have discussed two cases, no? For a MD function also we have discussed two cases. That you remember? What are the case? Just read it. If fa greater than or equal to 0, then this time it will be for capital Fx, isn't it? So if fa greater than equal to 0, then fx is positive all along a to b. That is, fx equal to fx minus gx is greater than 0. This implies fx greater than gx. If you understand this case only, then you can solve all the problems. But clearly, just we have discussed it for arbitrary function fx. If f greater than 0, it will be positive all along for m function. But there is another case also. That do you remember it? If fa no, what? fb. If fb less than equal to 0, then fx is negative on AB. Okay, it means fx is less than gx. Clear? I'll give you just 2 minutes time to do it for MD function. For MD, you just write it yourself. You'll remember better. You'll get 1 or 2 minutes time to do it. Just write it on your own and then discuss it. Case 1 and case 2. Those two cases you will always remember, no? This one and this one. Then everything done. A to B interval. For MD, we have taken the same thing. Fx equal to, you either prove MI or MD. If you have done MD, and then these two things will appear in your mind. A is always smaller than B for MD function. If fa less than equal to 0, then fa means capital F. Huh? Then fx less than 0 on AB. All along. That is fx minus gx less than 0. On the other hand, if b, this is b, no? If b greater than equal to 0, then fx greater than 0. This implies fx minus gx is greater than 0, that is fx greater than gx. Clear? Hope you all have understood. Now get ready for solving some very good problem which will clear the concept on proving inequation by using monotonicity of a function. This is our sum number 1. Prove that x greater than log 1 plus x, x greater than log 1 plus x for what? Log 1 plus x for x greater than 0. This we have to prove. So, first we check whether two functions are involved or not. Of course, one function is x, the other function is log 1 plus x. We are comparing, we are going to compare these two. So, start this manner. Let fx equal to x minus log 1 plus x. F dash x is what? 1 minus 1 by 1 plus x. 1 plus x LCM. It is 1 plus x minus 1 by 1 plus x. And about this sum, there is no confusion. Why? No confusion because it is given that this x is positive. Isn't it? So, can't I say that this is greater than 0? So, f dash x greater than 0. And what is the value of f0? That also you check. We are taking the interval 0 to x. There we are going to compare. Then it will be done. Interval Also you have to select not AB, 0 to x, because greater than 0 it is given. So f0 is what? 0 minus log 1, that is 0 only. Clear? So if dash x greater than 0, case of mi function, quickly you chalk out what condition going to be there, and f0 greater than or equal to 0, both are same thing. It is mi function, and if dash x positive, f0 also equal to 0. So if you start from, you cannot take less than 0, no? So you have to start from here, it is increasing. So what will happen here? If dash x greater than 0 means what? This implies fx is greater than f0. We have compared fx with f0 here. So this means x minus log 1 plus x greater than 0, that is x greater than log 1 plus x. Is monotonicity concept matching here? That function fx minus gx, we have taken x here and g here. Then you have proved it is, this implies fx is a mi function. And f0 is what? 0, it is proved. Mi increasing and the least value is 0. So other value has to be greater than 0. That's why we wrote, if you don't write fx greater than f0, there is no problem. Simply write therefore, as fx will remain positive, so this implies fx greater than 0. Because fa we got 0, 0x interval you have taken. So x greater than log 1 plus x. Now the sum we have started with to prove that x minus sin x is greater than 0 for x greater than 0 less than pi by 2. See how beautifully without graph it can be solved. We start with this. Let take fx, small fx, it doesn't matter. X minus sin x, we are going to prove x greater than sin x, no? Means x minus sin x greater than 0. So what about f dash x? 1 minus cos x. This is 2 sin square x by 2. What is your observation? What about this? Is it a positive quantity or negative quantity? Because the interval is 0 to pi by 2. This has to be greater than 0. So this implies what? And f0 is what? 0, the minimum value. The interval you are taking what? 0 to pi by 2. So f0 is 0. So other values has to be greater than 0. It remains positive throughout the interval for a mi function. So this implies fx greater than 0, that is x greater than sin x. It's going to be a very important tool for plotting graph also. Plotting graph will be one complete session, at least 2 hours, by using increasing, decreasing and maximum. Very interesting. We'll do it next class. Hope so. Next class, I mean second session. Because maximum minimum once started, it's a very big topic. Okay? Let us go for second problem. Prove that two inequations are there together. This is x, small x. Prove that x minus x square by 2 less than ln 1 plus x. At the same time, ln 1 plus x less than x. Clear? Understood? How to prove? Start thinking. Two function concepts will be there. This time we'll prove it MD, monotonically decreasing. And this time MD. If we take this minus this. If we take this minus this, we prove MI. So it's up to you what you take. Let me prove this one. Answer for this one, let fx equal to x minus ln 1 plus x. You understand the motive why I am taking this manner? I'll prove this is a decreasing function over there. So that I can say that LHS, this is something like fx. This is something like gx. We are comparing two functions. So you go on finding f dash x. F dash x is 1 minus x, 1 by 1 plus x, 1 minus x square minus 1 by 1 plus x. So what do you observe? F dash x is minus x square by 1 plus x. Then what will be your statement about f dash x? You can see that x is greater than 0. This is less than 0 for x greater than 0. This is minus x square. It will make the whole expression negative. 1 plus x positive, x square positive before the negative sign. It is definitely negative. And also, and f0, you check f0. The interval will take what? 0 to infinity. Isn't it? In place of ab, we have 0 to infinity. What is f0? 0 minus ln 1. That is also 0. Clear? So, f dash x less than 0 and f0 equal to 0. It is what function then? Therefore, fx is md in 0 infinity. Am I clear? Monotonically decreasing in the interval 0 to infinity. In the interval 0 to infinity. And the starting value negative. So don't you think that graph is going to be like this? So fx remain negative throughout the interval. Just we have told. This implies fx is less than 0. So this implies ln 1 plus x less than 0. Done? I have proved it. You try the second part. Prove that ln 1 plus x is less than x. So this is fx and this is gx. You let fx equal to ln 1 plus x minus x. Check f0. So f dash x minus 1. This is also negative. And similar situation. So this implies fx less than 0. That is ln 1 plus x less than x. Proved? Done? So now compare these two, the inequation is proved. Let's go for next one. Okay? Everyone understand? Prove that cos x lies between, this is cos x. This one is cos x. Cos x lies between this and this. Which one larger here? Of course, the second expression. So what you are going to prove? Cos x is greater than, less than. Is that clear? You try once. I give you 1 minute time. F dash x is coming what? Minus x plus sin x. We are, suppose we forgot everything. X greater than sin x, all this concept we don't remember. Or there is a very big sum. At this step you are unable to decide which one, whether this expression positive or not. Then you go for taking this one as gx, another function. Let gx is minus x plus sin x. So g dash x is what? Minus 1 plus cos x minus 2 sin square x by 2. And what is g0? Minus 0 plus 0, it is 0 only. And this thing negative definite. G dash x. Am I clear? So what will be your conclusion? This gx at least you can say negative. Therefore, gx is less than 0. But gx is what? Gx less than 0 means g dash x, gx all are less than 0. Gx is what? This function f dash x. So what does this imply? F dash x less than 0. But f0 equal to 0 you have seen. So what does this imply? Fx remains negative. That is 1 minus half x square minus cos x less than 0. This implies less than cos x. Clear? Understood? So, monotonic increasing decreasing concept is taken inside another monotonic increasing decreasing function. It helps us to solve the problem quickly. WBJEE sums are mostly based on this kind of, don't underestimate WBJEE question paper. Sometimes it is more difficult than JEE main paper. Okay? And many good colleges are there where you can study after qualifying WBJEE. Many good colleges are there in West Bengal. Okay? So this is proved. Try next part. Cos x less than that part. Again start the same manner. So let me finish it again by taking this function as gx equal to cos x minus 1 plus x square by 2, always the same way, minus g dash x minus sin x plus x minus x cube by 6. Isn't it? But again the same problem, although g0, if you find g0, we are going to consider the interval 0 to infinity, isn't it? g0 value is 1 minus 1, 0. But here we are unable to decide whether g dash x positive or negative. So what we will assume here, let hx equal to this thing, g dash x. I mean minus sin x plus x so h dash x is what? One minus cos x minus x square by 2. Again there is a problem. We are not able to decide. And very interesting to note that hx is coming 0 here also. To confirm whether it is actually negative or not, we take the help of another function, Lx. H0 is coming 0, yes. You take another function, Lx. Lx equal to h dash x, this minus x square by 2. What do you observe? L dash x sin x minus x, isn't it? Again there is problem. If you don't remember what to do, continue. L0 is 0. Take mx equal to L dash x. Now you'll get something. M dash x is what? Cos x minus 1 minus of 1 minus cos x. This is less than 0. And what about m0? 0. Okay. So the starting point negative and derivative less than 0. What will be the concept? Tell, go back. Gradually go back. This part will be less than 0. This part will be less than 0. This part will be less than 0. And this part will be less than 0. So this and this part, gx we have to consider. Gx less than 0. So this implies cos x is less than. Am I correct? You understand this iterative procedure? If you are not getting here, that function, the derivative going to be another function, isn't it? We are iterating one after the other. Finally, we go back to the original function. We decide whether it is, increasing, decreasing or not. Now I am changing the kind of problem we have solved so far. This kind of comparison also can be done. See, question, they have given 100 to the power 1 by 100 is greater than 101 to the power 1 by a. Very interesting. Everyone will be confused in this world. Suddenly, if somebody asks me, prove it though, I will think how to prove. I have many ways to prove. I use the concept of logarithm. From there, by log table, I can prove. The first one is greater than the second one. There is a way by using concept of maximum minimum it can be proved, but it nicely comes under this topic. inequality. So let us start. Let's see how to prove this one. You assume that function be equal to fx equal to x to the power 1 by x. Okay. Let us take the function fx equal to x to the power 1 by x. What is f dash x? You can state easily. It is e to the power 1 by x log x. So derivative will be e to the power 1 by x log x minus 1 by x square log x plus 1 by x square. Bring this thing back. X to the power 1 by x into 1 by x square common, 1 minus log x. Clear? Now what? Now what? Is 1 minus log x positive? We don't know. Is it negative? That also you don't know. But it is obvious 101 is greater than 100. Isn't it? I am taking three quantities here. Three quantities here. One is E. The other one 100 and then 101. I have taken these three quantities. Obviously, E is smaller than 100, smaller than 101. Now, you consider the interval e to infinity. You go on proving in this interval it is increasing or decreasing. That is very easy. Because unless otherwise stated, it is log x means ln x. What is the base here? You all know E. Isn't it? Now, is f dash x positive or negative quantity? This f dash x is a positive or negative quantity? I have taken the interval E. If you put x equal to E, just make this observation. If you put x equal to E, f dash E is going to be 0. If x greater than E, then f dash x going to be less than 0. Why? Because log x base E, if x is larger than E, it is always greater than 0. For x greater than E. For x less than E, it is less than 0. If x less than E. This is basic property of log. Unfortunately, it is not there. Log is only not there in CBSE syllabus. Wait, so this thing log x base C less than 0 for what? X less than E? I did not consider x less than E. Which part have I considered? X greater than E, log x will be greater than 1 even, because E by C is 1. X greater than E means it has to be greater than 1. I did not consider this part, only just go through that. Log 4 base 3, log 4 by log 3 greater than 1. Log 5 base 3 greater than 1. But log 2 base 3 less than 1. Isn't it? May not be negative, but less than 1 confirm. So this is greater than 1 confirm. So what about this thing? 1 minus log x for x greater than E, what will happen? Tell. So f dash x less than 0 for or if x greater than E. So what will be the concept now? And what is F0? F0 we need not find. What is Fe? Fe we found. What is Fe? Fe e to the power 1 by its quantity greater than 0. And Fe greater than 0. So for a decreasing function, fx is decreasing, it is proved. The function fx is decreasing, it is proved. And the starting point, the interval you have taken at the point E, it is what? Positive. F dash x negative. At the point E positive. And it is decreasing. So graph of the function approximately going to be like this. I don't know exact function, I did not plot. If I don't know, then what to do? I have to plot this way. So E lies somewhere like this. Whereas 100 lies somewhere like this. 101 somewhere like this. This 101 is smaller than 100. Decreasing function. So therefore, decreasing function, this f100, you take it more inclined, it will be better, no? More inclined. Otherwise, take like this. So f100 is greater than f101. f100 is what? 100 to the power 1 by 100 greater than 101 to the power 1 by 100. Proved. Okay? Clear? Done? So this way we can compare two or more quantities by using the concept of increasing decreasing function. This sum can be asked this manner also. 100 to the power 101 greater than 101 to the power 100. You please use the concept of increasing decreasing function. No maximum minimum. It will confuse you. Okay? Now let us take a bit difficult. May not be. Maybe. Let us solve this. 2x sec x plus x is greater than 10x. We are going to prove this. 3 tan x. Prove that 2x sec x plus x greater than 3 tan x. Sometimes you have to manipulate also with the terms. Let me show it to you. You start the same manner. Let fx equal to 2x sec x minus 3 tan x. So what about f dash x? Alright, sec x, tan x. We have to prove this is positive. So for that reason I am taking sec square x common. I am taking sec square x common. Okay. So this will be 2 cos x. This will be 2x cos x. No, 2x sin x, isn't it? Because it is sec x tan x. Sin x by sec square x. So it will be 2x sin x. This one cos square x. This one minus 3. What is the advantage? There is the advantage, we got a constant term. I don't have to think about this term. This is always positive. My concern is this. If this is positive, then everything is positive. But I am unable to decide over there whether it is positive or negative. So what is the procedure? Just I told you, let another function is this part. See, another way, I'm not taking whole derivative as a function because one part is confirmed positive, the other part I have to think. So that I'm pulling from there, assuming that is gx. Clear? Therefore, g dash takes okay. These two getting cancelled. What is remaining over there? Let's see. So this is, you take 2 cos x common. We have seen before, I am not doing it again. This is greater than 0 and in the interval x greater than 0. This inequation I forgot to write the restriction x greater than 0. Okay. So this is positive. This is also positive. So g dash x greater than 0. Also g0 into what? Just check it here. 2 plus 1 minus 3. That is 0. So this implies gx is greater than g0. Gx is what? This thing. G0 is 0. So 2 cos x what they have asked to prove. Oh, gx is a part of it. Sorry. So I cannot draw conclusion here. Just gx positive we have proved. So f dash x greater than 0. This implies fx greater than 0. Understand the concept? Step by step, you go back again if required. Do this one. This is for you only, exclusively for you. 2 root x greater than 3 minus 1 by x for x greater than 1. Prove this. 2 root x greater than 3 minus 1 by x. After getting this, people will think that RMO mathematics, AMGM inequality, maximum minima, so many things. But increasing decreasing concept will tell you very nicely, very quick. Just do it. This is for x greater than 1. So start the same manner. Fx equal to 2 root x minus 3 plus 1 by x. F dash takes 2 into minus 1 by x square. This is a positive quantity or negative quantity? Are you able to decide here? Yes. For x greater than 1, root x is less than x square, you must take it. 1 by root x is greater than 1 by x square. So this is greater than 0. Then go back again. F0 we need not find, F1 we need to find. What is F1? Because 0 they have not given, they have given 1 only. I check there only. F1 is 2 minus 3 plus 1, 0. It is that. F1. So it will be greater than 0. Plus 1 by x is greater than 0. So the proof is done. 2x is greater than 2 root x. This session will be completed with one JEE sum. Just one JEE sum will do. Okay? It came long back. This one. This one. If ax square plus b by x greater than or equal to c, where a, b, c are positive constants, then prove that 27 ab square greater than or equal to 4c square. Okay? How to start? It is different from other sums. Looks like that, but it is actually not. Concept is that only. Use of increasing and decreasing function. So start this manner. Let isn't it? Just check once. This is positive or negative? No condition given here. Can you say this one positive or negative? This one is a positive quantity or negative quantity? Positive. How? Why? So what? 2ax cube minus b will be greater than 0. Why? Because it is given ax square plus bx by c greater than or equal to c. It is given over there. Clear? So this implies what? This one going to be positive quantity. But for what value of x? X cube is b by 2a. So x is b by 2a to the power 1/3. Isn't it? It is given this thing positive. This expression positive they have given. So f dash x has to be greater than 0 for what? For x equal to this thing. My starting value is this. So can't I say that f of b by 2a to the power 1/3 is greater than 0? It means now fx is what? Ax cube by x. X positive they said. So this implies a b by 2a to the power 1/3 c C b by 2a to the power 1/3. This is not 1/3. This will be this thing. Check once because ax cube. So this implies b by 2 plus b greater than c into what is b by 2 plus b? Now cubing both sides. 27b cubed by 8 greater than check what is coming over there. Check. BB getting cancelled. 1b getting cancelled. These two also. So 27b cubed greater than 4bc cubed. This only we are supposed to prove, no? Check. So done. Many other sums are there. You will find from JEE paper and you will solve it. This only we are supposed to prove, no? Prove that 27 AB square, AB square. Oh, this is 1B is getting cancelled. B is there. 27 AB square greater than 4C cube. 4C cube. Clear? So this is the condition. I mean, this is the concept for proving inequalities in mathematics with the help of increasing and decreasing function. It's a nice concept. I hope you have understood. Clear?